ready to take your FastMCP authentication from development to production with enterprise-grade security. You'll see how to configure persistent encrypted token storage using Redis and Fernet encryption, ensuring your AWS Cognito integration survives server restarts while keeping sensitive data locked down. This production-ready setup handles everything from JWT signing keys to secure client storage, all through environment variables for maximum deployment flexibility.
Import OAuth. From FastMCP, import FastMCP. From FastMCP Server Auth Providers OAuth, import AWS Cognito Provider. From Key Value, AO Stores, Redis import Redis Store. From Key Value, AO, Wrappers, Encryption import Fernet Encryption Wrapper. From Cryptography, Fernet import Fernet. Hash production setup with encrypted persistent token storage. Auth provider equals AWS Cognito Provider. User pool ID equals EU Central 1 XXXXXXXXX. OAuth region equals EU Central 1. Client ID equals your wrap client ID. Client secret equals your wrap client secret. Base URL equals https:// your production domain, com. Hash production token management. JWT signing key equals OS. Environ JWT signing key. Client storage equals Fernet encryption wrapper. Key value equals Redis store. Host equals OS. Environ Redis host. Port equals int OS. Environ Redis port. Fernet equals Fernet. OS. Environ storage encryption key. MCP equals FastMCP. Name equals production AWS Cognito app. Auth equals auth provider.
This demonstrates the OAuth proxy pattern combined with secure credential management for enterprise authentication. The code bridges AWS Cognito's traditional OAuth implementation with FastMCP's authentication requirements, using a dedicated provider to handle JWT validation and token management. What makes this distinctive is its ability to maintain stateless security while supporting persistent sessions through encrypted storage. The pattern works by delegating authentication to AWS Cognito while maintaining control over token handling. The provider validates incoming JWTs against AWS's public keys, checks required scopes, and manages token persistence through an encrypted Redis store, ensuring security even across server restarts. This separation of concerns lets you focus on application logic while the framework handles OAuth flows, token encryption, and compliance requirements. This approach matters because it solves the common problem of integrating enterprise identity providers with custom services. You get production-grade security, MFA, SSO, group-based access, without implementing OAuth infrastructure, while the encrypted storage layer meets compliance needs for sensitive credential handling. The trade-off is added complexity in initial setup, but the result is a scalable, secure authentication system that works across distributed deployments. Let's break it down line by line.
Import OAuth.
Imports Python's OAuth module for environment variable access. This enables secure configuration by pulling sensitive values like API keys and encryption keys from the environment, not hard-coded in source. Critical for production security.
From FastMCP, import FastMCP.
This imports FastMCP, the core framework for building AI-callable tools. It transforms Python functions into structured APIs that AI models can invoke, handling serialization, validation, and execution.
From FastMCP Server Auth Providers OAuth, import AWS Cognito Provider.
This imports AWS Cognito Provider, the authentication handler for AWS Cognito integration. It manages JWT validation and token exchange with Cognito's user pools, handling all OAuth 2 flows required for production-grade authentication.
From key value, AO stores, Redis import Redis store.
Imports Redis store and a sync-compatible key-value storage backend. This handles persistent token storage in production, ensuring encrypted credentials survive server restarts. The async implementation prevents blocking during I/O operations.
From key value, AO, wrappers, encryption import Fernet encryption wrapper.
This imports Fernet encryption wrapper, a security wrapper that adds transparent encryption to key-value storage. It ensures sensitive tokens are encrypted at rest in Redis while maintaining the same simple storage interface. This is the decorator pattern applied to security wrapping storage with encryption without changing the underlying API.
From cryptography, Fernet import Fernet.
This imports Fernet from cryptography, a symmetric encryption implementation for secure data encryption. It provides the cryptographic primitives needed to encrypt sensitive tokens before storage in Redis, ensuring data remains protected at rest.
Hash production setup with encrypted persistent token storage. Auth provider equals AWS Cognito provider.
This instantiates the AWS Cognito Authentication provider for production. It handles user authentication and token management, replacing hard-coded credentials with a secure, scalable identity service. The provider integrates directly with Amazon's managed identity platform, offloading credential storage and validation.
User pool ID equals EU Central 1 XXXXXXXXX.
This specifies the AWS Cognito user pool ID, uniquely identifying your user directory in the EU Central 1 region. Required for all Cognito operations, it ensures authentication requests route to the correct user pool containing your application's users. The format combines region and pool identifier, following AWS's standard naming convention.
OAuth region equals EU Central 1.
Specifies the OAuth region where your Cognito user pool resides. This ensures all authentication requests route to the correct regional endpoint, preventing latency and potential region-specific configuration errors.
Client ID equals your wrap client ID.
This is the AWS Cognito App Client ID, uniquely identifying your application to the Cognito service. It enables secure OAuth 2 flows by telling Cognito which client is making the authentication request and must match the ID registered in your AWS Cognito App Client settings. Without this, token validation fails and authentication is rejected.
Client secret equals your wrap client secret.
This is the AWS Cognito client secret, authenticating your app with the Cognito service. It prevents unauthorized access by verifying your application's identity during token requests, a critical security requirement for production OAuth 2 flows. Never commit this to version control, use environment variables, or secrets management.
Base URL equals https://yourproductiondomain.com.
This sets the base URL for AWS Cognito's hosted UI and OAuth 2 endpoints. Required for production deployments, it ensures all authentication redirects and token exchanges use your custom domain instead of AWS's default URLs. Eliminates branding inconsistencies and prevents mixed content warnings in web applications.
Hash production token management. JWT signing key equals OS. Environ JWT signing key.
This sets the JWT signing key from environment variables, ensuring secure token generation and validation. Production systems must never hardcode cryptographic keys, so we pull this from the environment at runtime.
Client storage equals Fernet encryption wrapper.
This wraps the Redis store in symmetric encryption using Fernet, ensuring all stored tokens remain encrypted at rest. The pattern prevents exposure of sensitive authentication data even if the Redis database is compromised, while maintaining transparent access for authorized operations.
Key value equals Redis store.
This instantiates Redis store, a persistent key-value storage backend. It handles token storage across server restarts, preventing session loss in production environments. The Redis connection details come from environment variables for security and configuration flexibility.
Host equals OS, environ Redis host.
This pulls the Redis server address from environment variables, enabling secure configuration across deployment environments. Externalizing host values prevents hard-coding sensitive infrastructure details and allows seamless transitions between dev, staging, and production.
Port equals int OS, environ Redis port.
This converts the Redis port from environment variable string to integer, preventing type errors when connecting to the Redis server. Environment variables are always strings, but network ports require integers, so this explicit conversion ensures compatibility. This closing parenthesis terminates the Fernet encryption wrapper initialization, completing the nested configuration of encrypted Redis storage for JWT tokens. It finalizes the production-grade token storage chain. Encryption layer wrapping the Redis key-value store, ensuring secure persistence of authentication state.
Fernet equals Fernet, OS, environ storage encryption key.
This initializes Fernet symmetric encryption using a key from environment variables. It ensures all stored tokens are encrypted at rest, preventing exposure if the Redis store is compromised. The key must be kept secret and rotated periodically for security. This closing parenthesis terminates the AWS Cognito provider configuration block. It finalizes the production-ready auth setup with encrypted token storage, making the provider ready for use in the FastMCP initialization that follows. Closing parenthesis terminates the AWS Cognito provider configuration. This finalizes the auth provider setup with all required production-grade components: encrypted token storage, AWS Cognito integration, and Redis persistence.
MCP equals FastMCP. Name equals production AWS Cognito app. Auth equals auth provider.
This instantiates the FastMCP server with AWS Cognito Authentication. The auth provider we configured earlier handles all token validation and storage, while the name parameter identifies this instance in logs and metrics. This is the entry point where your Python functions become AI-callable tools. Production-grade OAuth integration. The AWS Cognito provider configuration demonstrates FastMCP's production-ready authentication pattern, where encrypted persistent storage and JWT signing keys work together to survive server restarts. The Fernet encryption wrapper is mandatory for production. Without it, OAuth tokens are stored in plaintext. This pattern scales from single server deployments to distributed systems by simply changing the storage backend.
The token that never touches the code becomes the most trusted part of the system.